Right this second, relentless sunlight is quietly trying to destroy your DNA. But hey, don't panic. Evolution actually developed an absolutely incredible, built-in solution to this exact problem, and we're going to break it all down today. Oh, and real quick, if you want more deep dives into the wild history of human biology, go ahead and hit like and subscribe to this explainer right now. Okay, let's get into it. So picture this. It is roughly 200,000 years ago, and you are a human standing in East Africa. There are no buildings, there's no shade, there is just a ridiculous, punishing amount of direct sunlight. Now, sunlight might feel great when you're hanging out on vacation, but constant, unprotected exposure over thousands of generations, that is a literal life or death biological threat. This intense ultraviolet radiation is just constantly bombarding your cells, it's obliterating your crucial folate levels, and it's quietly mutating your DNA. Basically, it's a massive environmental crisis that demands a biological solution, or early humanity simply doesn't survive. Okay, let's dive into this, because to survive this constant bombardment from the sun, human genetics engineered a brilliantly effective biological technology. The solution is what scientists essentially call nature's sunscreen. Instead of building physical shields, the human body adapted from the inside out, creating a molecular defense system that was perfectly calibrated to handle that intense equatorial radiation. And that brings us to melanin. Basically, it's a biological pigment that gives skin a darker color, but its real magic? It's entirely functional. Melanin acts like a giant molecular sponge, literally absorbing harmful ultraviolet radiation before it can penetrate deep enough to damage your cells. By neutralizing that radiation, melanin preserves the crucial folate we were just talking about, which is absolutely essential for healthy reproduction and development. So, in equatorial Africa, where UV radiation is among the strongest on Earth, having high melanin wasn't just some cosmetic trait. No way. It was a massive evolutionary advantage. It ensured that the very first modern humans survived long enough to pass on their genes. So the crucial point here is that for almost 90% of Homo sapiens' entire history, every single human lived in Africa, and every single human had dark skin. Because, look, evolution doesn't care about appearances, and it certainly doesn't have a master plan. Evolution's only performance review is really simple. Did you survive long enough to have kids? For hundreds of thousands of years, having dark skin was one of humanity's absolute greatest biological assets, easily securing a perfect score on that evolutionary performance review. Let's move to and see how this builds, because then, around 80,000 years ago, groups of humans began leaving Africa. They walked through the Middle East, they pushed up into Europe and Asia, and eventually reached Australia and the Americas. But remember, they didn't have maps, compasses, or weather forecasts. They just kept walking away from the equator, inadvertently marching straight into a massive new environmental crisis that their bodies were totally unprepared to face. As humans moved farther north, the environment shifted drastically. We go from the blazing, intense UV radiation of the African equator to colder, darker northern climates where ultraviolet radiation is significantly weaker. Now, at first glance, less UV damage sounds fantastic. Less sunburn, less DNA mutation, problem solved, right? Well, not exactly. Actually, scratch that, it wasn't solved at all. This drastic drop in sunlight introduced a completely new, hidden danger. We hit what we can call the vitamin D bottleneck. As humans migrated further north, the UV radiation dropped significantly, which caused crucial vitamin D production to completely fail. You see, the exact same sunlight that can damage your skin is also strictly required to help your body produce vitamin D. Without enough of it, your immune system suffers and your bones get weak. Suddenly, dark skin, which, remember, was so brilliantly engineered to block intense UV rays, was blocking way too much of this weak northern sunlight. As a natural result of this bottleneck, darker skin turned from a massive asset into a biological liability in the north, and lighter skin was naturally selected over thousands of years simply to let more light in. But evolution doesn't happen overnight. In fact, ancient DNA evidence has revealed the unexpected European. The very first humans who entered Europe, and even the hunter-gatherers living there thousands of years later, didn't actually look like modern Europeans. Astonishingly, the evidence shows they actually had dark skin paired with blue eyes. I know, it sounds like someone accidentally randomized a video game character creator, but it perfectly reflects how adaptation actually works. Pale skin only became widespread much, much later, as diets shifted with farming and local environments continued to exert pressure. And this brilliantly illustrates how incredible nature can be. Think of it like two students taking the exact same complex math test. They both get the correct answer at the end, but they use completely different formulas to get there. That is exactly how Europe and Asia independently evolved lighter skin. They face the exact same low UV environmental pressure, but they arrived at similar physical outcomes through completely different genetic mutations. In equatorial Africa, the pressure is intense UV, and the evolutionary solution is maximum melanin. Simple. But in Europe and East Asia, despite facing the exact same low UV pressure, they used entirely different genetic mutations to adapt. Nature doesn't follow a single, rigid blueprint. It arrives at similar destinations through entirely separate evolutionary roads. It's almost as if natural selection is showing off its problem-solving skills. Because of this incredible localized problem-solving, we have to completely shatter the modern illusion of neat racial categories like black, white, and Asian. Those categories, they're simple, clean, and completely biologically inaccurate. Human pigmentation actually exists on a massive, messy, continuous spectrum, from West Africans to North Africans, Middle Eastern populations to Europeans, South Asians, East Asians, Indigenous Australians, and Native Americans. The whole shebang. Humanity didn't just divide into a few neat boxes. It diversified continuously into hundreds of different shades based entirely on local environmental pressures. Now, what's really interesting about this slide is that it's staggering to realize 90% of human existence is our shared history. A history where we all lived in the same place, facing the same sun, and looking remarkably similar. The remaining 10% is our dispersed history. The visible differences we obsess over today, like skin color, represent a tiny, extremely recent blink of an eye in evolutionary terms. Beneath these incredibly recent superficial layers of biological sunscreen, we are all hiding how genetically identical we truly are. Section 1. One trunk, many branches. The shared family tree of humanity. Because if you go back far enough, the family trees of the lightest-skinned engineer and the darkest-skinned farmer merge perfectly into the exact same African populations. But you know, that journey is far from over. As our environments rapidly change, as we spend mostly all our time indoors, and as populations mix more than ever before, what color will human skin evolve into next? It's a fascinating, almost haunting biological mystery that's unfolding right now. So drop your evolutionary predictions in the comments below, and if you want to be there when we uncover the next massive piece of our 200,000-year biological journey, make sure you like this explainer and subscribe to the channel. You definitely won't want to miss where this story goes next.